So Scapy is a Swiss Army knife for network manipulation. For this reason, it can be used in many tasks and areas. It can be used in research in communication network, security tests, and ethical hacking to manipulate the traffic generated. It can be used for packet capture. It can be used for processing. It can be used for handling generating packages with a specific protocol. It can also be used to show detail of information about a certain packet capturing. You can use it to craft and manipulate network traffic. You can use it as a fusing protocols and IDS and IPS testing wireless discovery tools. So there's a whole lot that you can use Scapy for. It supports multiple network protocols, and it also provides API. This API provides the classes needed to capture packet across a network segment and execute a function of each time the packet is captured. So it allows to manipulate network traffic at a very low level. It allows to use protocol stacks and combine them. It also allows to configure all the parameters of each protocol. So before you can use Scapy, you must first and foremost install it on your Linux. So Scapy is not designed to work on the Windows. So you need to install it on your Linux, either on your Kali Linux or on your Ubuntu Linux or any variant of Linux that you are comfortable with. It allows the creation and manipulation of network packet of various types, implement functions to passively capture and sniff packet, and then execute action on this packet. So for you to install this to Scapy, you need to go to this website, secdev.org project. So this is where you get the instruction on how to install the Scapy. Just go to scapy.net project. So this is a project, and you can have a deep dive of what this is where to download. You can download it on YouTube, on GitHub. You can download it through your Python, or if you want to do the development version. So it's not supported by Windows. So if you want to look through the documentation, it's very easy to use and very, very easy to use. You can use it to automate your network. And there's some further documentation that you can leverage on here. Some other documentation that you can leverage on. You can use to automate. And you can also, there's so many scripts that you can download and also modify for your, you can customize. And you don't need to reinvent the wheel, but you need to understand the very basic before you can make use of a reusable script or modify or edit script. There are thousands of scripts that have been developed. So there are some thousands of there are lot of projects that have been developed with Scapy. You can look through some of these projects, and so that you have a feel on how on how to work around that. So it's a very powerful tool. So like a Swift Army. So you can download it from this website. So let's take a look at the different commands. You need to be very familiar with the Scapy command. So Scapy provides us with so many commands to investigate a network. You can use Scapy in two ways. You can use it interactively within a terminal window, or programmatically from a Python script by importing it as a library. So just like the way you use your Python, so you can use it interactively from the terminal. So these are the various commands. Let's just take a look a deep dive on all these commands. So let me go to my Kali. Okay, let me enter the password. Let me go to my shell. So it's always advisable for you to start your Scali. Use it, start it as a super user. For you to start a Scapy, you do sudo Scapy. So let's start with the first command, which is ls. This is the ls command. You can see. So let's display all protocols supported by Scapy. So these are the protocols supported by Scapy. Let's start from the beginning. You can see quite a number of protocols were supported. Quite a number. Protocols like ERP, Sniffing, so many protocols, so many DHCP. Also support DHCP version 6, various types of DNS, support DNS, support DNS SQL, support the EAP, quite a number of protocols. So if you want to use this, so definitely you can cram all of this. So what you must be able to know how to navigate your way around, so that depending on what you want to do, depending on your motive. So if you want to display the list of command and functions supported by Scapy, you do LSC functions. So these are the various commands supported by Scapy. Are the various commands, quite a number of commands, depending on what you want. You can see the sniff or the sniff command. You can use it as to sniff the packets, which we are going to display. We are going to demonstrate shortly. You can use it to trace route. You can use it to run the Wireshark. You can use it to write a list of packets to a pickup file. So you can store your packets to a pickup file, maybe for further usage later on. The conf display the various configuration options. CONF. So these are the various configuration options. For example, if you want to sniff in promiscuous mode, you do sniff promisc. So these are the various options. If you want to do a further diving on how to use a particular command, you type head. For example, if you want to do sniff, which we are going to be demonstrating shortly, so you can see you type head sniff. These are the different ways of using various options for sniff, which will be demonstrated shortly. Which should be demonstrated shortly. Let me copy this out. Sorry. So which will be demonstrated shortly, right? There's my notepad there. I think you can always go back to it anyway. Show display the details of a specific packet. For example, if you've seen a particular packet. So in all, Scapy supports about 300 networks protocol. You can have an idea with the ls command. So if you use the ls command, I think this what you see, and this is a further. And for the LSC, I think we've done that. So display the various functions available on Scapy. So let's start with the Scapy, sorry, with the sniffing capability on Scapy. If you want to sniff a simple packet, I told you that you can, if you go back to this, where's the function for sniff? I think this is my sniff. So this is how you use it. These are the parameters, the scan parameters. They also specify the interface with iFace. I think it's here. We can filter further this interface. So let's start. Try as much as possible to get your hand dirty on the other command, depending on what, because of the nature of our course, we'll be doing a lot of packet sniffing. So I'll be demonstrating how to use Scapy for packet sniffing now. So let's start with that, right? Let me open a new terminal. Let's open a new terminal. So remember to start your Scapy. So for you to sniff a packet, so the interface, if interface ETH0 is not available, you can use an IF config to look at the interface that are available on your system. So let's do a count of 3. If I want to just limit it to 3 or 10, we can do that. So that's how to sniff. It take a while before it comes out. Depending on what is going on my system, what I going on. Let me see and see that I can. Okay, I think it has come out. So if you want to display what is all the packets, PKTS, just plug PKTS. You can see that it pick only one UDP packet. Or let me see if we can pick more packets. I want more packets. Let's generate a packet. For example, let me just do a ping. Let's generate more packets so that will be more interesting, right? Let's generate more packets. Let's do ping. Okay, what that guy is going on. Let me visit some website, right? What am is going on right here? I want to be intentional to generate a lot of packets. Okay, I have 3 TCP. Let me see if I can, let me generate more. I want to keep on in like so that we have more stuff to work with, right? Yes. Okay, I think I have two TCP and 2 ICMP. That's okay for me. So let's so that's how to, if you want to view the packets, maybe the first packet, because I restricted this to 3 packets. So the first packet is what is ICMP packets. Let's look at the second packet. So depending on your system and what's going on your system, your packet might be different from mine. So as I'm doing it, please, your classwork, you also need to try that. Even on the lab, you need to try that on your lab materials. So these are the various packets, because I restricted it to 3 packets. So at the time of preparing this slide, I was able to get two UDP and 1 other packet. When I did dive, I was able to see my first packet was a UDP packet. My second packet was UDP as well. And my last packet was an ARP packet. So depending on what activity that's going on, you can I manually generate packet from your hand. So that's how to use Scapy to interactively sniff packets. So if you want to make sure that those packets are beautifully displayed, so you can do, for each of those packets, just do packet.show. If I want to beautifully display this guy, you can see that it makes more sense for me with this. So if I want to do the same thing for packet, the first packet, so you can see that's my first packet, which is ICMP packets. So if I want to do for the second packet, I will do dot show. You can see the second packet is ICMP, and we have only 1 TCP packet. So if you want to display you want to do the hex dump of a particular packet, you do hex dump, use the hex dump function. If you go through your functions, you will see that. So you specify the packets. Let's do hex dot packet to the last packet, which is the TCP packet, right? You can see that's the hex dump for my TCP packet. So depending on what, you can do the same thing for packet 0 and packet 1. So can we quickly try the same thing for packet, the first packet? You can see the hex dump. Let's do the same thing for second packet. So that's that. Now, if you want to, maybe for later use, you want to write the packet maybe as a pickup file, so that maybe for later analysis, because if you are doing a red teaming, you need to document all your findings. Maybe you want to probably later analyze the packet because there are a lot of enumeration that need to be carried out. So what you do, you can use the WRP cap. If you remember, the last function is WRP cap. So this WRP cap will write the packet to a file. So this is how to use it. So what you need to do, you just you write the function. WR means write packet. So you specify the name. Let me do sample 1.pcap. Do sample 1.pcap. PKTS. So you now do the read. Let's declare a variable called PKTS. For you to read the pcap file, RD pcap. Use RD pcap function. You specify the name, sample 1 dot pcap. You do sample 1 dot pcap. So having done that, you see whether you display the variables PKTS. So you can see there is a file called sample 1.pcap. So that file can now be later used later on. So if you want to see the value, read the value of the first packet, you can be reading directly because we've created a variable called PKTS. If you want to read the first packet, instead of you calling from it, because anything you do on the directory shell is not safe. If you close, but you can always reuse this guy. So you can see this is the value. You can also check for the value for the second capture. That's for the last capture rather. Second capture should be 1 right. Sorry, I'm still typing the same thing, don't mind me. So that's how to play with your. So for later on, you work on that. Now, if you want to filter, do a further. I think to filter your pickup file, your packet, use a filter command. For this, my packet, I think I have, can we do another packet? Let's do another packet called, let's do another packet. Let's just do more of, you introduce a variable, the parameter called filter. Let's introduce ICMP. while that one is going on, before we run the command, let's manually generate some IP ICMP command, right? ICMP packet, right? So let me just quickly come and do my stuff here. I think I've captured enough, right? Let's do PKTS. Okay, I've captured 3 ICMP. So what I can use to work with, right? So from here you can see. So let's look at the first packet. First packet is this, right? You can see that it's an ICMP packet. You can see the echo request. This is the destination IP. So this is my IP address. Pinging this IP or doing an ICMP scan on that IP. Sorry. So that's that. Now, if you want to summarize your sniffing with Scapy, if you look at this, let's go back to, I think this is my sniffing parameter here. If you look at the usage here, you can see there are a lot of things that we've not used here. So take your time and practice every other thing that's you can see this is the explanation for sniffing. You can use PRN Lambda functions. Let's introduce these guys. Let's introduce Lambda here. So you can play with some other usage. You don't need to cram it, but just make sure that you know how to use it. And so let's do an ICMP for, let's do 20 counts. Or we can go to 30 counts. Let's see. Let's do 20. Okay, let's do 25. My example, I just did. So you can see from my Scapy interactive share is displaying this online real time. If I want the details to be displayed nicely, but at least somebody give me the summary of all the I think I just love the display. So you can see if I want to get the details for all the 25. So you can see the way it's scrolling. So that's how to use Scapy for online real-time packet sniffing of your particular target. It's a very, very useful tool. I love it. I prefer to use it than the TSP dump or using a Wireshark. I will with this, I will be able to. So that's how to leverage on this. So I think to summarize this, you can use a show, which I displayed shortly. Now, if you want to reconstruct the packet as a string, you can introduce STR functions. So you can create a variable. Let's create a string variable, maybe ICMP underscore string. Let's call this variable str. Let's call it pkts. Let's say we want to read for variable for the first packet. So let's display this SCMP underscore str. Let's see. So this is a variable. So if I want it to be displayed in a more readable format, I can reconstruct it in a more readable format. I can say reconstruction, recon, str. Let me use reconnaissance so that I do not look as if I'm doing reconnaissance. So you introduce the eta function here. I see. So just like the way I introduce it here, right? If eta function, I see p underscore str, you close. So let me display. We can see. So display it in a readable format. So that's how to play with this packet sniffing. You can also convert it to base64. Probably maybe you want to, depending on what you want to do. For it to convert to base64 is pretty straightforward. You use export function. You use export function. What you just need to do, you just say you can, sorry, my screen, I'm trying to export. You specify the variable. That make a spelling mistake here. Sorry, export object domain. Use export object. Use the export object functions. Export underscore object, rather. Export underscore objects. So that's the base64 function. That's the base64. If you want to export it back, I think I can export it back. So if I want to import it back so that I'll be able to make meaning, you can use, so let me say, let's do new packet is equal to the inverse of export object is import objects. Import, sorry, my screen is freeze. Import objects. So having done the import objects, you can, I copy the value. So it take a while before the value will be displayed, depending on the speed of your system. So whenever the value is being displayed, you now do the eta of the new value, the eta function of the new value. So if you do that, you should be able to get the initial your register value of your ICNP underscore screen underscore str. So that's how to play with the sniffing function. So for the exercise, so no, I did a deep dive on the sniffing functions. Can you just pick any other function and play with it? You can do that in the next 2 hours. And so that's how to use Scapy.